Thank you everyone for attending the talk today, and I hope everyone has a glad summit so far today. So for this talk, we will be focusing on OpenTelemetry Collector, or OTel Collector for short. And I'm speaker Yang Sung. I work for Datadog and have been contributing to Collector upstream for a while. And in today's talk, we're going to cover some broader topics, basics of the OTel Collector and what consists of OTel Collector, the component and architecture. And lastly, I want to talk a little about the shared helper library called Exporter Helper, which happened to be kind of the topic of the last talk, like half an hour ago. And before I go, I actually want to ask, raise your hand if you are completely new to OTel Collector. Oh, wow, nobody. OK, so I'll try to go faster for the basis part then. So yeah, for the basis part, as we all know, or as most of us in the room know, like OTel Collector is a vendor-neutral agent that works via data pipelines. And the data pipelines are represented as DAG, internal like graph representation inside of Collector. And those data pipelines are defined with like YAML files in the configuration. So here's a very simple sample of OTel Collector config, which consists of a OTLP receiver, a batch processor, and the OTel exporter, kind of the simplest config you can ever have. And OTel Collector basically normally can be deployed in two modes. One is called like daemon set, where your collector is running on the same host as your application code. And the other is gateway, where you manage a fleet of OTel collectors, and you can do load balancing and routing and chaining, find out all kinds of stuff. And in this case, your OTel collector does not have to be run on the same host. Like it can be run on other hosts or like even a fleet of nodes. So moving on to the next, what makes the OTel collector? So the components of OTel collector can be various, and the 5 on the top are probably more common, and most of you in the room may already be familiar with them, which are receiver, processor, exporter, connector, and extensions. Those are all configurable in the end-user configurations. And I want to also talk about 2 less common components. One is converter, which does manipulation on the user-provided configs. For example, if you want to always add a, for example, extension to users' config to make sure that extension is always present, you can make use of the converter. And provider is kind of the interface or the component for providing the configuration. So configuration can, most of the configurations are from the YAML file, but it can also be supplied via environment variables or from the HTTP or HTTPS kind of thing. And converter and provider are not visible in the user configuration. So that's why most of the end users don't get to interact with them. But for like people who build the OTel distro, these 2 components can be particularly useful. And once you have all these OTel components, you will want to build a collector with OCB or the collector builder to generate the artifacts. And from like, OCB is kind of the most popular tool to build collector, but there are other tools out there as well. And I believe some of today's talk covers some other tools. But still, OCB is the most common one and most supported one. And OCB can build your artifacts either on the bare metal environments or like build and publish Docker images in containerized environments. And OCB works with what we call manifest YAML file. an example of this file looks like this. So you define the distro with like the name, description, and also you include the components of your choice. Here you can see that I can include some random, like kind of random component from my own repo and mix and match it with official components from the official like upstream repos. And you can do the same, like your components does not have to be hosted in the upstream, and it can be hosted at like anywhere in any repos, which brings us to the next topic. Want to talk a little bit about some common misunderstandings. Like I kind of used to receive a lot of these questions, like do my components, like my exporter, receiver, etc., had to be hosted in the upstream OpenTelemetry collector or collector country repo? Do they have to be included in the like what we call official OTel upstream releases in the releases artifacts? Or like as a library developer, do I have to recommend my user to use those artifacts from OTel collector releases? And the answer to all of this are no. So like I said, the OTel components, like any receiver or any exporter, can be hosted anywhere as long as they're a Go module. It can be in the upstream country core repo, or it can be in your own repo, or it can even be in a private repo with some trick. And if you are a library developer and you want your component to be easily discovered by a user, there's a registry, what we call OTel registry, on our official website, OpenTelemetry.io, and you can register your components there so that like anyone who go to the website can search and find your components. And again, like this OTel registry does not only include the components from the official repo. Even if your components is in your own repo, you are free to submit a request to register yourself in the OTel registry. And with all your own components, you can build your own distro with OCB. And OCB gives you a lot of flexibility. For example, like you don't have to bind to the upstream release schedules, and you don't have to be constrained with some of the build tag requirements from upstream. For example, like OTel official artifacts does not allow SQL. But if you build your own distro, you are not constrained to that. You're free to use any build tags. And also you can do your own versioning, etc. And like the other advantage for like building your own artifact with OCB is you can only include the components of your interest, unlike like the contrib artifact, which includes everything. And the resulting artifact is usually like smaller in byte size and potentially can have better performance as well. And next, I want to talk a little bit about like what happens when the OTel collector starts. The whole start sequence is quite complex. So here are 3 overly simplified steps. First, the OTel collector will try to construct what we call a conf map, which consists of the configurations of data pipelines from the feature flags, environment variables, and the configs. And then once we have the config, the collector will try to build the service telemetry as well as the data pipelines. And the data pipelines will be, like I mentioned, will be represented as a DAG, as a graph in the collector. And once we have all the pipelines ready, we will start the pipeline in reverse topological order, which means if you have like receiver, processor, exporter pipeline, the exporter starts first, and then processor, and then receiver. So whenever your receiver is up and running, your data will be sure to be sent to the exporter, so no data loss there. And by the way, like when you shut down your export collector, The shutdown sequence is the reverse of the start sequence, which means receiver will stop first, and then the processor, and lastly the exporter. So if you still have remaining data in your pipeline, those remaining data will still be sent through the pipeline, through the exporter to your destination. And here's the flow chart of the second step here, like building the DAG. The whole flow chart is too big, and credits to the upstream repo. So I only show the graph build part. As you can see, we will read the kind of iterate through the graph, read from the config, and create the nodes and edges, and also build all the components. So once you have this data pipelines, you should be easy to tell how the data flows through your OTel collector. One very useful tool I find is like this OTel bin.io, which can visualize your pipeline in like very simple flow graphs. So here I have kind of a very simple 3 pipelines, 3 metrics and logs, which only consists the receiver, processor, and exporter. In practice, your pipeline can be much more complex, which can include routing, fan out, fan in, and other stuff. But they should be, once you have the full configuration and definitions, you should be able to visualize them as DAGs on the OTel bin.io. However, OTel bin, one thing that OTel bin.io doesn't do for you is it does not tell you how the internal service telemetry flows in OTel collector. So here I have another graph which shows especially the internal metrics of OTel collector. How does that work? For traces and logs, those are kind of simpler, but for metrics, there are some catches. As you can see, there are 3 layers. The user's pipeline part is covered in previous slide, which you can visualize with OTel.io, and it gives you a nice flow graph. And what the other 2 layers do here is kind of both serving and scraping the internal metrics of OTel collector. So by default, the internal metrics of OTel collector are served with the Prometheus interface. As you can see here, all the user-defined components can emit metrics, and the OTel collector process itself can emit some infra metrics, like process uptime and other things. And all of these are collected with the internal meter, which is from the OTel Go SDK, and then exposed with the Prometheus server. And these Prometheus metrics are exposed by default as 8888. Then you can configure with the Prometheus receiver that scrapes from this port, this interface periodically, and then you will need to set up another pipeline to process and forward this internal metrics to other backends. And this by so far is still the default, but I know the community, OTel community, is trying to push people to use OTLP native for the internal metrics reporting, which I don't think we have enough time to go into too much details. So next, I want to also talk a little bit about a hidden but yet very useful library, the exporter helper library, which can be overlooked by many many users. And this happened to be talked a little bit about in the last talk. If you were in this room half an hour ago, many of the contents may be the same. So the exporter helper consists of a few configurations. By default, the exporter helper uses the in-memory FIFO sending queue. This queue holds up the telemetry batches to be consumed by the consumers in each exporter. And this queue can, you can configure this queue to batch based either on the request or the items in each request, or even the byte size, although the items and byte size configuration is still experimental. And in addition to the sending queue, you can also configure the retry settings in exporter helper. You can configure like, by default, like OTel Collector exporter helper has 5 seconds initial delay and 300 seconds overall retry timeout. And all of those can be tuned with the configuration like this. So here's the very simple, yet another very simple configuration showing how to configure the sending queue as well as the retries. There are some more advanced configurations like block count, overflow, and others, which you can find on the documentation in exporter helper. And third, the exporter helper can also configure to use a persistent queue instead of an in-memory queue, which again happened to be the focus of last talk. If you are in this room half an hour ago, the last talk talks this in very much details. So the persistent queue is often used together with the file storage extension to enable persistence. So a sample config again look like this. Like you will define a file storage extension and link it to the sending queue storage part in the exporter helper config. And the good thing about persistent storage, of course, like whenever your OTel collector crashes and restarts, you can resume the export on telemetry data from the last read and write index. And here's overview flow graph from the exporter helper library showing how this persisting queue works. And if you are an experienced OTel collector user, you may be wondering, like, some of the exporter helper functionality may sound like very much similar to a commonly used component called batch processor. So why do we want to use exporter helper rather than the batch processor? So here are some reasons. In general, like, exporter helper has more flexibility in the configuration. For example, you can configure the retry settings on failures for exporter helper, but you do not have such option for batch processor. Batch processor, on the other hand, kind of always drop data if data is rejected by the exporters. And also another common use case is for different vendor backend, they may have different requirements on the batch sizes or on the byte sizes. If you use batch processor, you will have to define multiple instances of batch processors to meet the requirements for different exporters. But with exporter helper, you can easily define it just within the exporter configs. And continuing on the comparison, exporter helper also allows you to batch on different settings, either on the items or on byte sizes, or by default on the request, while the batch processor only support like batch on request. And lastly, like you have to define the batch processor, while for exporter helpers, you kind of get it for free in the exporter. That being said, exporter helper and batch processor are not mutually exclusive. So we often see customers defining both the exporter helper, especially the sending queue, and a batch processor. So by today, the exporter helper is still in active development. And our general recommendation is like, if you prefer stability for now, you can continue use batch processor. But if you want to kind of be an early adopter of these new features in exporter helper, feel free to do so as well. And lastly, want to share some community updates from the OTel Collector, since we have been doing and coming next. So the community has been working on what we call the core collector 1.0, which is mainly like to stabilize the OTLP components, mainly OTLP receiver and exporter, including their dependencies, including the exporter helper that I just mentioned. And also the OTel Go community has been working on the OTLP native profiling signal. And for a collector especially, we are introducing a eBPF profiler distribution of OTel Collector. It's supposed to be out already, but there has been some problems. So hopefully it should be released next Monday. And we are also working on various improvements on the documentation from our website. If you have any feedback on the website, feel free to leave an issue or leave something in our Slack channel. And yeah, I think I have 4 minutes for question and answer if anyone has questions. Yes. Profiling?
Here, let me get
Oh,
you a
provider.
mic.
Yeah, so provider is for providing the configurations to the collector.
Yes,
Oh, yeah,
does OTel Collector currently support dynamic reloading of configurations?
Yes, that's, if you want to provide your own provider, you will need to implement that interface, like watching for config changes from the different provider sources, config sources. For example, from the files or from the HTTP.
And so, but this is supported, or do we need to modify it on our own?
We have, so collector contrib has a few built-in, like official providers. But if you want to provide your own provider, like customized provider, you can do so as well, like by implementing the provider interface.
Was your question about whether you have to implement the hot reloading yourself too? Or so for normal config files, that is supported not necessarily like as soon as the file changes, you have to give a signal to the collector, but then it will reload everything. And as long as all the providers under the hood also have implemented this reloading interface, that all should work. I actually don't have a question. I was just answering that. Sorry.
Yeah, thanks.
What does the collector use to instrument itself? Is that completely using the OpenTelemetry Go, or does it have something else?
Yeah, exactly. It uses OTel Go SDK.
You mentioned that the metrics are exposed via Prometheus, but how does the internal logs flow? Like, does it go back to the same loop as if it's a log coming from external, or does it have a separate path, the logs from the collector itself?
Logs from collector itself can, I think it's just written to standard out, but you can scrape it with some other log receiver as well.
The collector also supports the OTel Go file configuration. So if you want to export the collector's internal telemetry, its logs, traces, metrics, you can use OTLP or any of the supported file configuration exporters to export those data types.
So it can be routed back to the collector?
You could do that, although the recommendation is, especially if you're exporting directly using the Go SDK, do not use the collector itself to monitor its own internal telemetry. You should export it to some other collector or to a backend. Yeah,
there's a configuration for you to directly export the internal telemetry to a backend without going back to this collector pipelines.
On this slide, you mentioned that the Prometheus server is on by default. Is that still true? I think there was a change in just the last release that got rid of the ability to configure that, and so is it still hosted on that by default?
It's still on by default,
okay.
Unless you explicitly choose this OTLP for internal telemetry.
Got it.
The thing that changed was Yeah, what changed was the service telemetry metrics address is deprecated. It's not, it doesn't do anything unless you turn the feature gate back off. If you want to configure the default Prometheus exporter, you have to use the file configuration. And if you don't want to use the Prometheus exporter, you could supply an OTLP exporter instead.
Yeah. I think we're at time, so I'm happy to take any questions offline. And lastly, if you have more questions and want to get involved, you can reach out to us either on Slack or on GitHub. Thank you.